In section P.4 titled Lines in a Plane, we're going to go over a variety of things. First we'll talk about slope between 2 points. We'll talk about what the forms or equations of lines are. We'll go over a variety of different examples, how we write equations of lines, and we'll talk a little bit about parallel and perpendicular lines. What we probably will not spend time on in this video is how to actually graph lines, how you sketch graphs of lines. That will probably be saved for either in class or another video later on. Let's begin by talking about slope of a line. When we talk about slope, we're talking about how steep is the line. Okay, and it's measured in a specific way. It's always done the same way. We define this to be, slope is defined this way. It's defined as the vertical change divided by the horizontal change. You may already know that. You may have actually even seen it described this way. Since the y-axis is vertical and the x-axis is horizontal, and the Greek symbol delta means change, this means change in y divided by change in x. So how do we do that? If we had a line and 2 points on the line, so this point is x1, y1, and say this point is x2, y2. How do we find that vertical and horizontal change? Well, the change between y1 and y2 would be their difference. y2 minus y1. The change between the x1 and the x2 would be their difference. x2 minus x1. That would give us a measure of how far we've gone from one point to the other, horizontally and vertically. So we define slope, typically labeled with the letter m, to be y2 minus y1 divided by x2 minus x1. In other words, it's just the difference of the y's divided by the difference of the x's. Vertical change divided by horizontal change. Now, just a couple of quick examples finding the slope between pairs of points. First example, I need in the numerator to be the change in the y's, and I can subtract them in either order. I could do this y 7 minus this one 12, or I can start this one 12 minus this one 7, and it really doesn't matter. So I'm just going to take them in the order they're given, 7 minus 12. Now what does matter is, since I started with the 7 and the 7 belongs to this point here, then in the denominator when I do the x's I must start with the same point. So I have to now, I'm locked into going with 4 minus 2 in that order. So I get a slope of negative 5 divided by 2, or if you prefer to pull the negative out in front, a slope of negative 5 halves. Okay. What that means, and it's maybe easier to interpret here, well actually we can interpret it two ways. What that means is to get from one point to the next point on the line, you're either going down 5, right 2, that would be negative 5, positive 2, or you're going up 5, left 2. That would be placing the negative down here. So you'd have a positive 5 and a negative 2, and you go that direction. Either way, the points are going to fall on the same exact line. Now let's do one more example. Here the slope m, I'll flip it around this time, why not? I'm going to start with this point, so I'm going to do 4 minus, and I want this y negative 2. Since I started with this point here, I must start with the same point on the bottom of the fraction, so 2 minus 3. In the numerator, the minus negative becomes positive, so we get 6 divided by negative 1. Typically, even though we could preserve this as a fraction, you'd probably see it eliminated with the negative 1 on bottom. You just see a slope of negative 6. But it is implied that it would be negative 6 divided by 1. So that would imply down 6 and right 1. Or, in this form, up 6 and left 1. Alright, next let's go over 3 different forms of lines. The first 2 are generally forms that you might be asked to write the line in. General form looks like this: ax plus by equals c, where a, b, and c are integers and a is greater than 0. So we generally like to lead positive, and we like all these numbers to be integers, so non-fractional, non-decimal values. The next one, slope-intercept, is one that everybody should be very familiar with, as you've dealt with it quite a bit. Y equals mx plus b, where the m is the slope and the b is the y-intercept on the graph. The final one, point slope, is typically the equation that you use when given information to get to one of these two. Point slope is y minus y1 equals m times x minus x1. To use this equation, you need 2 things. You need a point and you need a slope, hence the name point slope. So we're going to use this generally on, I think, just about every problem now going forward. Even if it says write it in this form or this form, we'll use this equation right here to get to one of these two. This first example asks us to write the line in slope-intercept form, so that's important. Slope-intercept form, given that the line passes through a point and has a slope given there. So we're given 2 things about this line. We're given a point and a slope. We have an equation titled point slope that needs just exactly those 2 things that we're given. Okay? Now, in point slope, the point that you're given, okay, the point, I didn't write this on the last slide, the point goes in for the x1, y1. The slope, of course, goes in for the m. So we're plugging into these 3 spots in the equation. The y and the x of the equation are going to remain the y and the x. We don't mess with those. So, plugging in, we have y minus. Now we're putting the y value of the point, which is negative 2, in for the y1 behind that minus, equals slope negative 1, x minus, and we're putting the x value of the point, negative 3, in behind this minus. So of course these negatives become positive. Clean it up, we got y plus 2 equals negative 1, x plus 3. Now keep in mind, we are trying to get to slope-intercept. We're trying to get to y equals mx plus b. It's y equals, not y plus 2 equals. So that needs to come over. The plus 2 does. I'm going to first distribute the negative 1. So we have y plus 2 equals negative x minus 3. Now we can subtract the 2 and we'll get to our slope-intercept equation. Y equals negative x minus 5. This next example asks us to write the line in general form. Okay, so a little bit different. Let's keep in mind what we're going towards. The general form given the line passes through this point with this slope. So I'm going to begin with y minus y1 equals mx minus x1. I have my point. So the y value of the point equals, the slope is 1.5. I'm going to put it in as a fraction. 3/2 is the same as 1.5, x minus 4. I'm just doing that because typically slope is seen as a fraction, so why not go ahead and do that. So let's see, we have y minus 4 equals, I'm going to distribute 3/2, so we get 3/2 x minus 3/2 times negative 4 is negative 6. If I add the 4 across, so we end up with y equals 3/2 x minus 2. Now I have this in slope-intercept form. Let's take it to a general form. Now, two things to consider with this general form of the equation of the line. Again, one, no fractions. 2, so I want the x to be positive. Okay, so let's keep those two things in mind as I do this. I think we can get there in a couple steps. If I want there to be no fractions, I'm going to multiply this whole equation by 2. I'll cancel out the 2 here. So that makes this equation equivalent to 2y equals 3x minus 4. We just doubled everything, essentially. Now, to get to the general form, again, the general form, so this right here, notice the x and y are on the same side of the equal sign. I need these two terms on the same side, and this one has to be positive because I want the x to be positive. So if I want the x to be positive and I want the y on the same side as the x, I'm going to leave my x right here. I'm going to bring the 2y over here. I'm going to take this minus 4 over to this side. Okay, so that would be done by adding 4 to both sides and subtracting 2y to both sides. Okay, let me write the answer right over here. I'd end up with, on one side of the equation, 3x minus 2y. On the other side, we'd have 4.